Hello everyone, welcome to Conf42 2026. This is Srinivas Talasila. I have 19 plus years of information technology experience, worked with companies like AT&T, Adobe Systems, HP, and presently I'm working with SAP America. Today's topic is to discuss on a high level what are the challenges and key factors that needs to be given a deep thought while moving ML systems from experimental labs to production systems, and what are the infrastructure challenges that needs to be given a thought and considered while planning phase. With that, quickly go through the agenda. Today's agenda would be to go over on a high level what are all the key challenges. We can talk more on challenges to help us understand why this is important and what are the key factors that needs to be considered to overcome the production use case challenges. And we can also go over modernizing infrastructure availability and why it is needed to have more scalability, resilience, reliability, also observability and security compliance requirements for the production systems, and available options that needs to be looked in the market to address some of those challenges. And IBM Cloud SoftLayer Foundation, it has a good backend infrastructure which gives us good performance metrics and resilient as well. So we can go as an example what it gives us. Pillars of resilience, what are those? Like high availability, security and performance as previously mentioned, reliability, also scalability, zonal deployments for high availability. And we can also talk about people and process, as this is a must need for production systems where teams will be cross-functional teams will be coordinating and using the systems for use cases depending upon the use, and what are the deployment patterns and how cloud native approach will help us to maintain, simplify the deployment patterns to version maintenance and reproducibility, and for also the auditing. This is a compliance requirement which will help. And finally, we will be talking about key takeaways. Let's start talking about the challenges, what we have from moving ML systems from experimental labs to production systems. The key things in experimental labs where the data will be pure, and we will be more focusing on benchmarking the performance metrics, use cases. But in production systems, there are a lot more challenges because of the drift management, use case scenarios varies. It's not always the same, and the scalability requirements and the latency comes into play, performance metrics, and the availability as well. That is the reason why these are the things that needs to be given a deep thought while planning a move of ML systems from experimental labs to production systems. These are some of the key comparisons what we have from legacy systems and current production demands and what modern platforms offers. The modern platforms is more towards cloud native approach, and in the market we have many cloud providers which does that, and cutting edge technologies, and with the integrations, all the reliability aspects, security aspects, and also the monitoring, alerting, observability made easy with the cutting edge cloud agnostic or cloud native approaches. Now let's see about IBM Cloud SoftLayer. So this gives high performance, bare metal and virtual compute options. Also, we have global availability zones in IBM Cloud SoftLayer. Network backbone optimized for larger data transfers, which is key aspect to consider while moving to a production systems to overcome any bottlenecks on throughput, IOPS, or it could be latency. So IBM provides some of these cutting edge technology options which will help productizing the ML systems. Now, what are the pillars of resilient ML infrastructure? The key pillars would be high availability. High availability, as we discussed before, on a high level, while planning and designing phase, we will have to think about the use case scenarios like multi-zonal deployments, which cloud provider provides us with zonal features, which has their presence across multiple zones and offering its customers to deploy across multiple zones with minimal latency. And those benchmarks needs to be looked at depending upon the use case. That way, we have clear understanding on what will be our latency patterns, performance metrics, IOs. And this is mainly also for disaster recovery. When we have multi-channel deployments, it is good that we will have another zone available. And disaster recovery. What in case everything goes down, right? So a different site from backup strategies. There are many air gap solutions, or you call it immutable backups. These are the things that needs to be given a thought while considering a disaster recovery. That will minimize our recovery times. And we should also consider which cloud provider provides this as an option in terms of the time to recover should be minimal, and that should be understood before designing a disaster recovery plan. And security by design. Yeah, zero trust. These are must in today's infrastructure, as we are mostly leaning towards cloud agnostic and cloud native and multi-cloud adoptions being a top priorities for most of the organizations. The observability and security compliance are key metrics for any organization. And we will have to look into a cloud providers who does that, like who provides default blocks for DDoS attacks or for ransomware attacks. Those has to be thoroughly gone through while designing this security by design, and who are all the players in that area. And the design of the production ML systems. High availability architecture is a must for seamless activities and for ensuring the SLAs, we call 4 nines or 5 nines, whatever the numbers are, to meet those SLA benchmarkings. High availability architecture plays a critical role. And the apps, what kind of load balancing distributed traffic across zones we will be using. And if it is a stateless, serving server models without a local state, which will help us minimize our failover times, and the availability will be much more higher. And there should be a mechanism. We should also have fault tolerance detection and take a preventative measures for failing over the systems to available systems to serve the traffic. And health recovery is also must. And in this model, we should cover like over monitoring, preventative measures, thresholds, setting up a triggers for failovers, or next step, the correctable action items to recover, and how do we fail back to. These are the things that needs to be considered for high availability architecture to achieve a good high level uptime of the systems. And how do we sustain ML workloads? These are some of the model trainings for the real case production ML systems. depending upon the types of the workloads we have, each presenting unique challenge for robust system designs. Again, this will be on case to case design. This has to be given, and how do we rate limits, for example, rate limits for unpredictable traffic spikes. That has to be clearly defined and benchmarked. That way, it doesn't affect the other users' traffic. If there is an unpredictable traffic in one of the use cases, it should not impact the other case. For that, real-time serving, rate limits, all this will help come into a play. It could be in the case of DDoS attack as well. How do we limit? How do we predict that? How do we set alerts? And what are the limits that the traffic should be blocked from a particular source in a use case scenarios? So that is how we will be more looking into sustaining models for production systems. And this plays a vital role, zero trust segmentation for ML systems. As we discussed in my previous slide discussions, security plays a vital role. And for this, it could be customers' auditing purpose, and the compliance requirements has to be clearly defined and well known in advance. And the drift management should be there to ensure unknowingly something got changed on the infrastructure. It could be rate limits, it could be allowed port listing, or it could be allowed software versioning or the release versionings. So for all that, we can also make use of cloud native approach. Most of the public cloud providers are providing this as a feature. I think it's a paid feature, depending upon the use case scenario and what kind of network design that we choose for the ML systems. That has to be clearly given a thought. What are the available options and cloud providers who provides these information and available for usage. Depending upon the test case scenarios and benchmarkings, SLAs, these can be considered. And mainly this is to data set protection, the training environment installations, the QA there of the training of the testing beds should be separate from the quality checks. And from the quality checks, the production system should be isolated, where always the changes should come from the lower environments to the higher environments, post testing, thoroughly testing, and post security clearance. And there should be a model serving security, which is like endpoints protected by an API authentication, rate limiting, as we spoke in my previous slide discussion, and network segmentation policies. If we are choosing a NSC level at the cloud, NSC rules or ACLs, these are all the things that needs to be predefined, and most of the cloud providers provide these by default as when we are consuming their service for zero trust segmentation. And let's talk about the framework element, right? Operational controls. This is required for ensuring there should be an asset management to ensure the versioning and maintenance releases are appropriately managed and effectively. And for this, also we have identity and access management for modern registries, which is nothing but access management. A privileged access management is available with most of the cloud providers, which will clearly define the roles, rollbacks, and responsibilities. A different version where we can limit the users depending upon the use case scenarios and the pipelines usage. So this will be through this we can bring in more observability at the user levels on who needs to access the production systems and what can be done by defining the clear roles and the rollbacks. Using these can be integrated from the cloud, or if we have our At the orgs that in the past that I worked, they have their own forest management, which is DNS or user management, use of Active Directory. And that can be integrated with cloud providers, privileged access management rules by defining is accounts, and only the people who are part of those accounts will be able to perform the defined roles according to the role defined. And audit logging across training and serving pipelines. This is critical for any kind of debugging or to know exactly what happened in the environment or while executing the pipelines, what is the source, what are the targets, what happened, and if there is a failure, where did it go wrong for debugging. This is going to help us. And compliance validation for regulated ML workloads. And there should be a defined model frequently to know, to meet compliance requirements. And this is also important to automate security scanning of container images. Whenever there is an image that we wanted to deploy or make use of, it has to, there should be a model that it should come to the environment with proper scanning, meeting all the security and compliance requirements and the versioning requirements. Then only it should be allowed to the repositories for the use within the environment, specific environments, from QA to production, or it could be from testing environment to production. And performance, now let's talk about the performance metrics and what are the available tools that we need to consider. And there are public clouds which will offer these when we consume their services, or we can have our own. Every org has its own tools like performance metrics that can be measured for the resilience, right? And model serving uptime, it provides us the uptimes of all the assets in the production infrastructure, availability and interference endpoints, failover recovery if there are any use case scenarios in the production systems, and automated recovery time from zone level failures. And if there are any security breaches, right, lateral movement incidents and segmentation is deployment. And these are all must things to consider. And a training throughput, improvement in distributed training performance, all these things are must while for a measuring platform resiliency. And every organization will have its own benchmarking and SLAs, so it has to be planned accordingly while considering to define performance metrics. Now let's talk about people and process. So this is some of the areas, right, where it requires more than technology. That is a cultural shift towards shared responsibilities across organizational. When security and reliability ownership extends beyond the infrastructure teams to include data scientists, ML engineers, ML ops practitioners, and platform engineers, organization create systems where resilience is built in every stage from model development to deployment and monitoring. This distributed ownership model ensures teams collaborate on shared outcomes rather than simply handing off responsibilities. The result: ML systems that are robust, secure, scalable by design, not as an afterthought. And this has to be, as we were talking about more on high availability, performance, benchmarking, security, availability, scaling, right? These shouldn't be an afterthought. These should be considered during the design and planning phase. Because with the people and process, right, now the responsibilities are shared, where engineering teams deploy or test in the labs and roll out a solution. And the operational teams productize it, right? Product teams productize it, and operational teams to ensure availability, uptime, and scalability of this particular product. So all these teams are critical and they have to go hand in hand by having a clear understanding and on end-to-end deployment of these systems into production, where these key metrics are met. So this is the cross-functional responsible model looks like, and you can go through this slide, which will give you a clear understanding on how the cross-functional responsibility should look like. And depending upon the organization use, there could be a number of teams, even more teams like change management, vendor management. All this comes into play depending upon the kind of cloud we chose when this comes into play. And we will have to closely work with vendors or the cloud providers to ensure they're well aware of any situation or any support required for any deployments or availability. And there should be also a clear visibility on vendor cloud providers maintenance, which should not impact the availability of production ML system. So by ensuring that it is highly available architecture is applied there. Now let's talk about deployment patterns, cloud native and hybrid. Depending upon the typically when we are moving from legacy to cloud, we end up using hybrid, or depending upon the zonal presence of the cloud providers, we might end up using multi-cloud. So these are the things that we need to consider. What model, what adoption? Is it a hybrid adoption or a completely cloud native adoption or multi-cloud adoption? What is required for the use case scenarios? Depending upon the use case scenarios, this has to be given a deep thought during the design and planning phase. And again, this is also not a afterthought. This has to be given a good thought before even starting, or I would say before considering a locked architectural design for ML systems. And let's go over some of the areas where which talks about infrastructure foundation matters, embedded security. This has to be early, as we discussed before. Design for failure. What is our recovery strategy? High availability, and what are the key components involved in it? How do we define and distribute responsibility? This is between the teams, and there should be clear AC defined between the teams on who is responsible and who is accountable for work, and how the hand holding should be. That should be clearly defined, operational model. And last, measure and iterate. So establish a clear SLOs for availability, performance, and security, then continuously improvement against them. Because from time to time, there will be difference, and there will be different hotfixes that will be coming in. There will be different findings where we will have to quickly adapt depending upon the criticality. Some would be less vulnerable, some would be highly vulnerable, and some would be highly critical, where we'll have to immediately address those to make sure that the data is not compromised or the environment is not contaminated with these vulnerabilities. So with all this will ensure that building a robust, secure, and scalable ML systems, when we take all these metrics, what we have gone through on a high level, will ensure building a robust, secure environment for production ML systems. And these are the key takeaways from this session. And thank you very much for giving me an opportunity to present this and patiently listening to me. And if you have any questions, or if you agree or do not agree, please do feel free to drop me a message to my email, or I'm there in LinkedIn. Yeah, feel free to post your questions, comments, and I will be glad to answer as many as possible. Thank you.